One of the simplest methods of finding out how much gold in a specimen is literally just to crush them down and extract the gold. But sometimes we don't want to do that because the specimens just like this one are worth a lot more money if they're left intact. And this is simply because this shows the geology of the area, and to a collector, that is an incredibly important thing. A lot of people on my channel have suggested using acid to erode some of the quartz and ironstone to reveal the gold. However, in my area, the gold isn't one solid piece. It's what's called free mill gold. This is free floating pieces of gold trapped all throughout the quartz and ironstone. And that means if I used acid, it would literally just fall apart. These are the things we're going to use to get a rough estimate of how much gold is in there. A bucket of water, a plank of wood, the scales that go up to 100 grams, and a little rig to suspend my piece of ore. This is called a specific gravity test. It's not 100% accurate, but it will get you a rough ballpark figure for how much gold is trapped inside a rock like this. The first step is super simple. We need a dry weight of our specimen. 33.67 grams. Next, I'm just going to tear off my rig that suspends the piece of quartz in the water, because we don't want to include the weight of this rig in our final results. Then we put our piece of ore into the rig. Now we're going to hang the rig off the scales with the piece of ore floating in water. And that's going to give us our next measurement. 19.73 is its suspended weight. Alright, I'm having some problems with the maths, and I'm going to explain something that you're going to run into if you're doing specimens that are a mixture of quartz and other minerals plus a small amount of gold, compared to doing a piece of quartz with a lot of gold and not a lot of other associated minerals. This is the specimen you saw me dig up on my last video, and you can see a ton of pitted ironstone at the top where the gold is contained. The problem with that ironstone is it's a different specific gravity to quartz, and it's full of air pockets. This, however, is a specimen I dug up a couple of years ago that is mostly quartz. You can see the gold in the middle of it, and it's an absolute screamer and quite heavy. The difference is the composition. In the first specimen I showed you that I dug up just a couple of days ago, we have a mixture of minerals that all weigh different amounts, whereas the second one is primarily made up of silica or quartz. So we can almost guarantee the specific gravity of that material. Now, I've already run the tests, and I know that dry this weighs about 65 grams. And when I have it suspended in water, it weighs around 40. The actual rig weighs 7.5 grams, so you got to take that off. Now for the super fun part, all the maths. There are two different formulas. This is the complicated one that works it out in ounces, and then you can transfer it into grams. So you got the dry weight minus the wet weight gives you the difference. The dry weight divided by the difference gives you the specific gravity of your piece. The specific gravity of your piece minus the specific gravity of quartz. You take that number and you divide it by the difference, which is what you worked out up here, and that'll give you a number. Then you take that number and you divide it by a constant of 25.98, and that'll give you your rough gold total in ounces. When I apply that formula to that second piece, I get 2.89 grams, which by the feel of it is roughly probably correct. So I worked it out another more simple way, and that's this formula here. To work out the gold content, you want to do 3.1 times its wet weight minus 1.9 times its dry weight. And that gave me an estimate of 3.38. The only true way to know how much gold you have in a specimen is to crush it and extract the gold. But like I said before, we don't want to do that because we want to keep it as a specimen piece. So I've got a 0.5 gram variance there, but it puts me in the ballpark of how much gold is in that specimen. The problem is, the other specimen has a whole bunch of ironstone and air mixed with it, and therefore these formulas aren't giving me an accurate result. The first formula I showed you gave me a 1/2 ounce total. And I'm telling you now, there ain't no way there is 1/2 ounce in that thing. I would hazard a guess there's somewhere around 1 gram looking at it with my experience of crushing all the other ones. And the other formula gave me a negative weight, and this is all due to that ironstone content. The larger your specimen is with the more gold, the more accurate accurate this test is going to be as long as it's contained within a host rock that is primarily made of one thing. In this case, we want it to be silica or quartz. At any rate, I hope this video has been educational for you, and I think we've both learnt something that you can't really rely on a specific gravity test when you're dealing with a lot of ironstone.